Alright, so today I want to look at integration, and I want to do integration again by differentiation. So we're going to do U sub. And I have really interesting integral here. An integral we're going to look at two. So, first integral we're going to look at is going to be the integral of x plus 8 times the square root of 16 x plus x squared dx. And then the second integral we're going to look at, which I'll divide like this, is going to be the integral of 6 plus tan theta to the fourth power times secant squared theta d theta. So, I first want to write on the top something that you guys may remember from Calc 1, and that is that d over dx of f that has a function inside of it is equal to f prime with the same function inside times g prime. So I'm just going to have that up there for reference. So we see in our first integral that we have something rather, tricky. But we see that if we differentiate this inside function, you'll get, 16 plus 2x. Well, 16 plus 2x, if we divide that by 2, we'll get this. So that is our g. So let's do that. Let's set u equal to 16x plus x squared. Then we're going to get du is equal to 16 plus 2x dx. Now, let us take 1/2 of du, which will be equal to 1/2 of 16 plus 2x times dx. So that would be equal to 1/2 du, and if we factor that through, we'll get 8, and then here we'll get just x. So now we're left with the outside function. So if we substitute this back in, we get that dx will be equal to du 2 8 plus x. So now we can substitute this into our integral. We'll get the integral of x plus 8 times square root, we set u equal to that, u times du over 2 x plus 8. Now let's simplify this. We're going to get rid of this, and then we'll bring out the u in front of our integral, so 1/2. If I said u, I meant 2 in front of the integral. And then we're going to be left with u. Well, let's change this u to the power of 1/2. And for those of you who do not know, u to the 1/2 is equivalent to the square root of u. I'm left with du. So this is just the power rule. If you don't remember the power rule, it's going to be u to, let's just do it in terms of x. So we're going to do x, n plus 1 over n plus 1. So we're going to get 1/2 times u to the 1/2 plus, 1 is also equal to 2 over 2. 2 over 2. So we're going to write 2 over 2 divided by, n is, again, 1/2. So it's going to be 1/2 plus 2 over 2. We're going to get like a plus c at the end. You know, they always say don't forget those plus c's. They're very important later on, especially in differential equations. So now we're going to get 1/2. Let's simplify the inside. Or it's going to get 3 over 2. 1/2. Well, that's going to be 1/2 to the 3 over 2 again. Plus c. Again, we can simplify this. We can times the top and bottom by 2/3. 2/3, which is equivalent to timesing it by 1. And we'll get 1/2 times 2/3 u to the 3 over 2 plus c. Well, we see that we can just smack that right there. Get rid of that. We don't need that. At 1/3 u to the 3 over 2 plus c. What was our u equal to? If we look up here, we said u is equal to 16x plus x squared. So we're going to say u, just writing this down from above, plus x squared. So let's sub that back in. We're going to get 1/3 16x plus x squared 3 over 2 plus c. And we see that if we differentiate this, right, well, we're going to have to use a chain rule. We're going to have to call this function g or something and then differentiate it. And we'll get this on the outside. So anyways, let's do this one. Let's see what's going on here. This looks a little bit more complicated. Most people, they see trig functions and they get scared. And that was me back in when I took calculus too. So let's think about the derivatives. What derivative would give us secant squared? We know that d over dx of tan of theta is actually equal to secant squared theta. But how can, if this is inside this function, how can we divide, how can we get rid of this? Well, let's think about this. If we set this equal to u, right, and we differentiate u, we'll get u, well, this goes to 0. This is a constant. And this will go to secant squared. So we're going to be left with secant squared. So let's try this and see if it actually works. My intuition says it will. So we're going to get tan of theta. We're going to get du is equal to, well, it's d over d theta of 6. That's 0. And d over d theta of tan of theta, well, that's just secant squared. And that's going to be d theta. So we get that du is equal to secant squared theta d theta. So we get that d theta is equivalent to du over secant squared theta. And we'll substitute that back in. So now we're going to get our integral. Our integral is equal to u to the 4th. And if you don't see that, that whole thing becomes u times secant squared theta du over secant squared theta. Now we see that all our variables are in terms of u, so we can now integrate. We're going to integrate u to the 4th du, which now becomes, well, let's apply this same rule, right? This rule right here. I'm going to circle it in red. Let me make it bright. This rule right here. And we can actually talk about where that rule comes from in a later video, and there's a lot of interesting ways in looking at it. So let us do that to this function. So we're going to do u to the 4 plus 1 over 4 plus 1 give us 1/5 u to the 5 power. So now we can substitute back in all of this. Well, just this. Because that is all that we're left with. So we get 1/5 6 plus tan of theta to the 5th power, and don't forget your constant. And that is the integral. So I hope this video was very helpful. If you have any questions about any of this at all, we can talk more about specifics, whys, that's very important. So if you have any whys to what went on in this video, let me know in the comments and I will make another video addressing that. Thank you so much.